Today we will solve the problem named minimum operations to form subsequence with target sum. So the question is, you are given a zero indexed array nums consisting of non-negative power of 2 and an integer target. In one operation, you must apply the following changes to the array. Choose any element of the array nums of I such that nums of I is greater than 1. Then we can remove it from the array, or we can do, add 2 occurrence of nums of I divided by 2 to the end of the nums. Okay, so what we have to do, return the minimum number of operations you need to perform so that nums contains a subsequence whose elements sum to target. If it is not possible to obtain such subsequence, return -1. So you all know a subsequence is an array that can be derived from another array by deleting some or no elements without changing the order of remaining elements. So we'll see with the example. Here the example is nums 1, 2 and 8, target is 7. So what we have to do, we have to find a subsequence from this nums array which elements sum will be equal to target. So we can do two things. We can take any element, or if we don't want to take, we can escape it. Now another thing we can do, we can half any element if it is greater than 1. If it is greater than 1, then we can half it into we can half it and make the 2 occurrence of it and push it into the last index. What they said, add 2 occurrence of nums of I divided by 2 to the end of the nums. So we'll do the same things which they are saying. So let's try it. So we have this nums. First of all, we will check when we'll return -1. They are saying if it is not possible to obtain such subsequence, then return -1. So when it is not possible to return, when it is not possible to find the subsequence, when the sum of the nums elements, if the sum, if I'll calculate the sum, here the sum is 1 plus 2, 3, 3 plus 8 is 11. Here the sum is 11. Let's say our target will be, let's say our target is not 7, our target is 12. So can we find any subsequence with this nums? We can't, because our target is greater than nums, the sum of the elements of nums. So we will never able to find the sum, because we can delete some element, or we can half some element, or add its 2 occurrence, but we can't add another element from outside. So we will never able to find the sum. So we'll say simply, first the -1 condition is if the sum of the nums element is less than target, then what we say, we'll say you return simply -1. Now the case is now the case is when we how the now the case is we have to count the operations. So what we'll do, we'll simply first sort this array. For our simplicity, we'll sort the array and we'll start from the last. Why I'm doing this? Because every element is power of 2. Every element is power of 2. If some element is less, means some element is satisfying the target, means it is if less than target, then we can simply add it and then we can move to smaller element. So let's see what I have to do. Here I am at 8 and the sum is, sum is s, sum is 11 and I am at 8. So what are the options that I have? One option is I simply escape and don't take it and come at this element, and another option is I can divide it into 2 elements, 4 comma 4, and add on the end. And third option is I can take this 8 into my subsequence. Okay, so 3 options I have. So firstly, when I was solving this question, I was thinking that it is a DP problem, that I can take it or I don't take it, I take it or I don't take it, and another option is I can make it half and I can take it. So three things I was taking in mind, that I can take element as it is, and I can escape, and I can half it, and then I can take it. So it is not a DP problem actually. It is simply a greedy problem, because these are power of 2. if if our target, let's say it is 7, if our target is let's say I am having element 4. If our target is having 4 in it, means it is having 7. How we'll represent the 7 in bits? It is 1 and 2 and this 4, 0. So it is 7. Am I right? So if it is having 4 element 4 means 4, the bit of element 4. 4, how will represent the 4? 4 is this. So if it is having this, then we will simply take it, and we will start from the right, from the maximum element, so that we can escape the minimum element which we don't want, because 4 can be made from 2 and 2, or 1, 1 1 1 1 1. This also possible, but we'll start from the this rightmost bit, so that we can escape most other elements. If it is having the 4, if it is having the bit of 4, then we can take it. So I have these three options. So first what I'll do, the sum, I am having the sum. So I'll start from the 8. Now let's say 8 is I have taken 8 in A, and I have popped it from the nums. Now in nums, what I am having? I am having 1, I am having 1 and 2. Okay, this is my nums. What I can do now? I have some options. The target is 7. Now I will check. What I'll check, if the remaining sum is 3. Am I right? Remaining sum is 3. So I will check if remaining sum is greater than my target. If it is greater than my target, means I can fulfill my target's need with this remaining sum. Why I will take it? I will not take. I'll simply say, I am just escaping it. What I'm saying, if my target is, let's say my target is 3. So I will check if 3 is less than or equal to my remaining sum, then I don't have to take this 8. I'll simply say you just popped and I am not taking it. Okay, but in this condition my remaining sum is 7, my sum is 7, target is 7, and remaining sum is 3. So 3 is not greater or equal than 7, so I have to take it. Now what I'll check, this alone A, if this is less than or equal to my target, then only I can take. No, if it is greater than my target, then how I can take? I will not able to take. So my target is 7 and the element is 8. Can I take it? I can't. So what I'll do, as they have mentioned, what I can do, I can add 2 occurrence of nums of I by 2 to the end. So I'll simply, what I'll say, now I'll make my nums is equal to, I am having 1 and 2. I'll simply add 4. 8 divided by 2, 4, and 4, 2 occurrence of 4 at the end. Am I right? So now again I'll start from the last. I'll check if by eliminating this, the sum I am having, the left sum I am having, if it is greater or equal than my target. If it is greater or equal than my target is, target is 7. If it is greater or equal than my target, then I can simply escape this 4 and I can continue with my remaining elements. So its remaining sum is 4 plus 2 plus 1. It is 7. 7 or 7 is less than or equal to 7. So I can escape it. Now I have popped it. Now I am at 4. So if remaining sum is now I am at 4, I have popped 4, I have taken 4 and popped it. Now I am having remaining sum is, when I will pop for the remaining sum, what I'll do, when I am popping, I'll just the sum I am having, I'll simply say sum minus the popped element, so I can find the remaining sum. So remaining sum is less than is greater or equal than target? No, so I have to take it. Now I'll check if it is greater or equal than target, then I will not take, because I have to take the elements which is less than or equal to 7. So 4 is less than equal to 7. Yes, it is 7. It is less than equal to 7. So now I will reduce my target to 3. 4. I'll uh, I'll decrease the 7 to 4, because 7 minus 4 is 3, because I have taken the 4 in my element. Now what is sum? Sum is 11. First I have popped it. So 11 minus 4. 11 minus 4 is 8, and 8 minus 4 is now 11 minus 4 is 7. Sorry. So 11 minus 4 is 7, and 7 minus 4 is 3. So my sum is now 3. Now I am at 2. Again I'll check the uh, uh, if uh, after eliminating 2 from the sum is 1. Sum is 1 now. So if sum is greater or equal than target, then I'll escape it. It is not, so I have to take it. Now I will check again and check if the number is less than or equal to target, then I'll take, then I'll only able to take it now. So yes, it is less than or equal to my target, so I'll simply take it, and I will reduce my target to 3 minus 2 is 1. 3 minus 2 is 1, and I will pop it. And similarly from the sum also I'll reduce it. So my sum is now 1. My sum is 1, and then again I will check the element I can take or not. I can take, so I'll make my target to 0. So till then my target is not equal to 0, I will continue the loop. I will continue the loop and do this again and again, the last element. So you can understand the code, then you will be able to clear your things what I have done. So simply I have taken a long accumulate sum. So what I am doing, I am just to finding the sum of the elements of nums. So accumulate sum plus is equal to nums of 5. Now what I'll check, if this accumulate sum is less than target. If it is less than target, then I will, in any condition I will not able to find the target. So no, there is no meaning of then operations. So I'll simply return -1 here only. Now result is 0. What I was doing, I was iterating from last, and what I have said, I'll check for the rightmost bit firstly. So I'm sorting the array. I have sorted the array. Now while my target is 0, I will do some things. So I have taken the last element nums.back, and I have popped it. I have taken the last element and I have popped it. Now what I'll check, if my accumulate sum, what sum I am having, if this minus last element means I am finding the remaining sum. If this remaining sum is greater or equal than target, if it is greater or equal than target, then there is no need to take this element. I can find my sum with the remaining sum. I can find my target with the remaining sum. Means I am finding the remaining sum. If the remaining sum is greater or equal than target, so what I will do, I'll say I am escaping this element. I can continue with the remaining sum. So from my accumulate sum, I am removing this element. I have popped it already. Now if it is not there, if it is not the condition, then I will check on which element I am at last element. So if last element, if it is less than or equal to target, then only I will able to take it. If it is not, then I can't take it. So if it is less than or equal to target, simply I will take it, and I will reduce it from the accumulate sum, and similarly from the target also, because I have taken it. Now if it is not less than equal to target, if it is having some part of my target but not the whole part, it is having some bit of my target but not the whole bit. So simply I will do, what I'll do, I will push half of the value, half of its value, two times, two occurrence at the end. So as soon as I am doing this, I have I have chosen this third option. So I have made one operation. So I am adding 1 in my result. So I'll continue this while till my target is greater than 0. If my target is 0, then what I'll simply say, you just return the result. So at any point I will able to find my target, because I am having the power of 2. I am having the power of 2. So at any point, maybe my target is 7. Let's say I am not having 1. I am not having 1, I am having 8 and 2. I'm having 8 and 2. If this sum is greater than target, 8 plus 2, 10, 10 is greater than target. So I am not returning minus 1. Then how I'll find 7 now? 7 is odd number. This is even. So how I can find 8? What I'll do? 8 is 4 and 4. Am I right? 8 is 4 and 4 and this is 2. So 4 I'll reduce. I am at 3 now. So 3 is greater than this. What I'll do? Simply make it 2 and 2. Make it 2 and 2. I'll reduce it. I'll make it 3 minus 2 is 1. I'll make it 1. Now I am not having 1. What I'll do? I have taken 1 2. So I'll make 2 2. I'll make 2 2, but means I'll half it and add 2 occurrence of 1. So 1 I can find in any way. I can find all numbers in any way, because any element of having the what which is power of 2, I can make it to 1 1 1 1 1 1 1 1 1. Are you getting my point? So any sum I can find, maybe its operations are big, means to find the 8, if I am having 16 only, 16, so I can find the 8 by dividing it. Are you understanding? Means to find the 37, I can divide the element by any times. Any element can be sum up from the ones only, because I can take 37 one. See, I can take 37 one and I will able to find 37. Maybe it will take much operation, more operation, but I am able to find. If the sum is greater than my target, then I am in any condition, I will able to find the target. So simply it is not the DP problem, it is a greedy problem. We'll start from the last. If the last most bit, if my target is containing it, then I am having some options. Then I will try to find these options. I'll check these options. If it is fulfilling my need, if it is fulfilling, then I'll take it, or then otherwise I will add it to occurrence of it. So this is very easy problem. You can go through it once again and check it. If I'm submitting it now, and it is submitted successfully. Thank you.